today we're going to start talking about systems of equations. Okay? So the first thing we're going to talk about today is just the definition of system of equations, what a system is, what the answer is going to look like. Okay? So a system of equations is two equations used to compare situations. Okay? You don't need to write down those examples, but you need to write down what it is. Okay? Two equations used to compare two situations. And all of these problems that we're going to do, you're going to have an x answer and you're going to have a y answer. Okay? You're going to have two equations, each with an x and a y in it. Each is going to be a linear equation. Okay? And so your answer is going to be an x and a y value. And that x and the y value is the solution. Okay? And that solution is the point where the two lines intersect. So my two equations are y equals 3x minus 4 and y equals 2x minus 3. Okay? So you're going to have a graph, okay? And on that graph, I'm going to have these two, they're both lines, right? If I were to graph these two things, they'd both be lines. We know how to graph those? Yes? Okay? So I'm going to have two lines, and those two lines are going to intersect at a single point. That point right there is your answer to the system of equations. Okay? So the point is your answer to the system of equations. So, whenever you have a problem throughout this chapter that says solve the system of equations, we're going to talk about a bunch of different ways to solve the system of equations. But you're always looking for that point where those two lines intersect. Okay? It's really important to understand that that's what you're looking for. Alright, I'm going to give you some time to copy all this down. And then I'm going to discuss it. Okay, so up here we have our different types of consistent systems. And my two types of consistent systems are dependent and independent, right? And down here I have an inconsistent system. Okay? So what these graphs are going to look like, I'm going to kind of compare these to dependent and independent people. Okay? Do you have any friends who are dependent? Maybe some friends who are dependent on their boyfriend or girlfriend? You have friends like that? Do they ever leave each other's side? No. Might they as well be one person? They might as well be one person, right? Okay? So think about that for dependent systems, they might as well be one line. Okay? So you're going to have one line, and if it's dependent, there's infinitely many solutions, okay? Because remember, we're looking at the solution to a system of equations is what? The solution to a system of equations is what? Where the two lines cross at, right? Okay? Now, dependent systems, or dependent people, might as well be one person. Where do those two lines cross? Where do those two lines cross each other? Do they cross at just one point? No. They cross at that point, and 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 that point. Right? Every point on that line they cross at. So how many points do they cross at? Tons of them, right? Infinitely many points, right? So if you end up with two lines that are exactly the same, okay, you end up with infinitely many solutions. Okay? And that is a dependent system. Just like dependent people, they might as well be one person. Those two lines might as well be one line. Make sense? Okay? So let's move on to independent people then. Okay? If you have friends that are independent, you see them every once in a while, but they go off and do their own thing too, right? Okay? So they might cross your path once, but then they go back off and do their own thing again. You might see them Friday night at the football game, but for the rest of the week you don't really see them all that much. You have friends like that? Yeah? Okay. Those are independent people, right? So, independent lines, an independent system of equations, crosses at 1 point. Yes. Okay. An independent system crosses at 1 point, just like independent people. They cross your path every once in a while, but then they go off and do their own thing again, right? So here you both come, and you cross each other, and then you go off and do your own thing again. Okay? So that's an independent system. And that obviously is just going to have one solution that's going to look like a point. Okay? And then we move on to these inconsistent people. Okay? You have friends that are inconsistent. Do you see them very often? Inconsistent friends you never really see. You can't really ever count on them, right? They might say that they're going to be there, but do you really know if they're going to be there? No. Okay? Those are inconsistent people. So are you going to be friends with them for very long? So are you ever really going to cross their path? No. So inconsistent people, okay? An inconsistent system of equations is going to be parallel lines. Okay? They're never going to cross your path because you're sick of trying to make plans and then they don't show up, right? Those people are inconsistent. Okay? Those systems are inconsistent. They're never going to cross each other's path. So what do you think our answer is going to be? No solution. Because there is no point where they cross, right? So do you guys see the difference between all those different types? Yes? Okay? So when it's asking you what type of system there is, think back to this. Okay? What kind of friend is this? Okay? Are they right on top of each other? They're always together, they never leave each other's side? Those are dependent. Okay? They cross once. Okay? Those are people who they're around every once in a while, but then they go their own way again. That's independent. Okay? And inconsistent people, you're not friends with them because they're a pain to deal with because you never really know if they're going to be around or not. So they never cross your path. So those are parallel lines. Okay? Does that make sense? All right. So those are the big ideas that we're going to be using all chapter. Okay? Now we're going to move into the first way to solve a system of equations. Okay? We're going to talk today about solving a system of equations by graphing. Huh? Consistent is dependent and independent are two types of consistent. Alright, so to solve a system of equations by graphing, we start off with two equations, right? A system of equations is always going to be two equations, okay? And if we're going to graph those two equations, the first step is probably going to make sense to be what? Solve for y, okay? If you need to graph equations, we know that in order to graph an equation, you got to have y by itself, okay? So that's obviously your first step, is you're going to solve both of the equations for y. Because now instead of just graphing one line, you're going to graph two of them. Alright? After you solve them for y, you can graph them both and find the point where those two lines intersect.